The characteristics is on the L shape. Okay, did we discuss this question? You can see my slide, right? Did we already discuss on this topic, on this star yourself, where the pitot tube is combined with the manometer?
Belum lagi, doktor.
Okay, belum lagi. So let's see this one first. Figure shows the pitot tube combined with mercury manometer, and it is connected to a pipeline that used to measure the flow parameter in the pipe. The pipeline diameter is 50.8. So basically we measure the velocity at the middle of the pipe. So you can see the dotted line is the middle of the pipe. So we put the pitot tube at the center of the pipe. And then calculate the velocity and flow rate of water at point 1. Okay, so when it is combined with manometer, you need to use your previous knowledge on hydrostatic pressure, where we measure pressure. What is the formula we use to measure pressure, hydrostatic pressure? When you learn on hydrostatic, apa formula to find pressure? Hmm? Nuri Najla. We use rho GH kan?
Yeah.
Yes, good. Okay. So, bila dapat soalan on manometer ni, we back to previous lesson lah. Kita kena split into limb. We have left and also right. Okay, so you can see from this one, the left limb, we have one type of liquid sahaja. Okay, we have this fluid. For right side, we have mercury and also water. Okay, so if you can see here, macam mana you nak baca benda ni? Left ni adalah point 1. So based on this mercury punya level, point 1 or point 2 is higher. Difference of pressure lah kan? So the difference of pressure is this one. Okay, here. Okay, we have the difference of pressure. P1 minus P2 or P2 minus P1 sama. Okay, so we have the left limb, like I mentioned, the pressure rho GH untuk water. This is for water and also mercury. Okay, if they write down like this directly, maksudnya dia guna rho H lah. Dia guna lambda H. Okay, because this formula also can be write as specific weight H. Okay, and then equating both sides, so you get the difference of pressure, which is P2 minus P1 is 31.396 in kilopascal. Okay, and then we can apply the Bernoulli equations to find the velocity. So we cancel the elevations, not because it is no elevations, but because the elevation is same. So we can cancel. We cancel the V2 because that At point 2, there is no elevation, no movement. Okay, the fluid is at rest. So we have pressure 1 minus pressure 2 and also the velocity of point 1, which is velocity entering the pipe. Okay, and then kita boleh substitute value of different pressure. And finally, we get the velocity of 7.924. Okay, from this one, you can find the Q using the continuity punya formula, which is Q equals to AV. So area is pi, diameter is here, 0.508 square divided by 4. And then time with the velocity. Okay, please check. Is this the correct answer? 1.606. You get the same answer?
Yes. Yes.
Yes, doctor.
That is the examples. Okay, let's see on the value in details. So this is the stream tube, or we call it as pipeline. This pipe have the converging. Okay. The smaller size of the pipe, we call it as throat. Okay, so when you see the word throats in questions in solving problems, throat is referring to the smaller size of the pipe. The larger pipe, we call it as a pipe saja. Okay, the size of the pipe is, for example, 50 cm. The velocity of the throat, so throat is referring to converging, or we call as constriction of the pipe. Okay, and then for each point, we call it as sections. It has a different area because of the diameter. Of course, it has a different pressure and also different velocity. Okay, it has the own parameter. Okay, and then we also measure the H. The H is referring to hydrostatic pressure. So if you can see here, when the size of the pipe is smaller, pressure dia lebih tinggi. Dia naik kat bahagian yang smaller pipe. Okay, so there is a difference of pressure, which is H for section 1 and section 2. Okay, and then we also measure the potential energy on the Z. Okay, Z is always measured from the datum, and it is always vertical height. Okay, even though we have the incline manometer here, but for Z, we always measure the vertical height. Okay, we cannot measure any inclined plane. So kalau pipe ni ada angle, you need to use theorem Pythagoras to find the vertical height. Okay, contohnya kita ada inclined plane 2 meter. Tapi kita tak nak guna this as the elevations because this is the inclined height. So we need to find this one. Y. Okay, vertical height. Okay, so we have Z1 and also Z2 for the stream tube, and another Z is for the manometer. Elevations for the manometer. Okay, so details on that, it consists converging conical tube, call it as throat, samalah. Throat is referred to smaller diameter of the pipeline. Okay, so using the manometer, we can determine the pressure difference, but we also can calculate using the formula. Flow rate, kita boleh dapat flow rate daripada formula lah. Tapi kalau guna manometer ni, dia punya direct reading adalah pressure difference. And also using the formula, the velocity. Okay, so we can apply Bernoulli equations for a venturimeter. Okay, so we can apply Bernoulli equations. And lastly, we use formula of continuity to find the discharge. Samalah formula dia. Okay, so this is the derivations of the formula inside the venturimeter. There is a pressure difference between 0.1 and 0.2. We considering pressure level at X must be the same in both limb. So that's why we do equating the both equations on left and right ni. So kita boleh cancel either one, and finally when we want to find the V, this is a formula for V. Okay, this one kena ingat lah. So basically you akan belajar flow measurement of 4 devices kan. So ada pitot tube, venturimeter, orifice, and also notches and weirs. So untuk pitot tube and venturimeter, pitot tube and orifice, and basically the notch also, you use the formula yang sebelum ni. V equals to square root 2GH. Okay, only venturimeter je dia guna yang ni. So senang je lah nak ingat sebenarnya sebab ada dua formula je untuk flow measurement on device, which is V equals to square root 2GH, and also this one for venturimeter. Okay, so we need to consider the density of manometer. Man is manometer, so basically it is mercury. Kita tak tukar lah. Density fluid dalam manometer, dalam venturimeter is always mercury. Cuma yang berbeza is fluid on the pipe. Fluid dalam pipe tu sometimes oil, sometimes water. So this is density of the fluid. Okay, the big capital letter of A is referred to the area of the pipe. Smaller a is throat, area of the throat, and we divide also with the area of the throat. Okay, so this is V theory. Sama je dengan soalan dengan konsep sebelum ni. If you want to calculate the actual velocity, what we need? We need coefficients kan. So we have coefficients darab dengan V theory. Okay, this is V actual. Actual sama dengan CV darab V theory. Okay, let's see examples with the value. So we have the details also in questions, and also you can refer to the picture lah. Dia dah bagi information kat picture sekali to make you more understand. So this is throat, diameter is 120 millimeter. So of course you need to change the one to meter first. Okay, discharge Q is 0.15. Inside the pipe 9 is oil, and inside the manometer or venturimeter is mercury. Okay, the pressure difference is the H, 0.63 meter. The question asks us to calculate the coefficient discharge. So kat mana dapat coefficient discharge ni? Of course daripada Q lah. Q ada CD times area times velocity. Clear? Okay, so we can use directly the formula to find the V. Substitute all the value. 2.981, H ialah 0.63, and then this is the density for mercury, density for oil, area for pipe, area for throat. Okay, we calculate the area using formula of circles, pi d square over 4 or pi r square. Okay, then you find the coefficient discharge where the Q actual, where we get the 0.15. Mana kita dapat Q theory? Q actual, sorry. Mana dapat nilai 0.15 ni? Okay, it is given in the question. Okay, dia dah bagi Q actual. So divided by the Q theory. Q theory ialah area darab dengan V. We use this V. Okay, the area is always referring to the area of the pipe, bukan area of the throat. Okay, we don't use the area of the throat, we use the area of pipe here. Okay, and then we get the coefficient discharge is 0.15. The coefficient discharge is actually always in between 0 to 1. Okay, tapi tak adalah wajib. Sometimes ada je soalan yang tak dapat in between this. But it's normally or typically is in this range. Okay. Let's see another examples. Okay, so this one dia dah bagi form. There is a incline 45 degree. So mesti dah letak bagi jarak tegak kan? Because we need a vertical height. Dia bagi incline height. So incline height dia 2 meter. Tak nak lah, kita nak dia tegak. So here is 2 meter. Here is 45. So you can use cosine tangent to find the y, which is the vertical height. Diameter is given. The fluid inside the pipe is oil. They also give you the velocity at point 1. But we don't know the velocity at point 2. So this one you can calculate lah. You can calculate. Maksudnya 200 mm, velocity dia 2 meter. Kalau 100 mm, berapa velocity dia? Okay, and then the question asks us to find the pressure difference across the 2 meter length where we can ignore the losses of energy. So it is an ideal fit, so we can follow Bernoulli principle. Okay, let's see punya gambar aja, picture. Okay, so we have different diameter, angle, 45. The pressure difference is H. And we have the elevations of Z1 and Z2. So which one yang kita nak kena cari ialah Z2 Z1 ni kita consider 0 lah. Sebab kita nak cari difference from Z1 pada Z2 kan. Okay, so list out all the information given. So from this information, you boleh dah dapat agak yang you kena cari dulu V2. Sebab kat sini missing. Missing pieces ni kena cari dulu. Okay, just write down the Bernoulli equation first. And then cari dulu V2. Okay, we use continuity equation here. This one as I mentioned tadi, you kena cari nilai Z2. We are using sin 45, sin 45, y over 2y. Y is the Z2 elevation. Okay, finally, we can measure the difference between pressure 1 and pressure 2. Okay, so this is in meter. Tapi kalau kita nak calculate guna pressure difference inside the manometer, we need to use the pressure in unit kilopascal. So that's why here, we change the pressure in meter, which is pressure energy lah. This is pressure energy. So we need to change to pressure in kilopascal. So kita darab dengan rho G. Okay, sebab formula dia P equals to rho G kan. Dapatlah H, head. So now when we want to find the P, it is H darab dengan rho G. Okay. Dan bila dapat dalam unit kilopascal, we can use inside the left limb and right limb. Finally, we can find the H. Dia tanya kat sini, the difference in level. Maksudnya H lah. Okay, we need the pressure difference and also different in level. Different in level, this one. This is the first level. This is second level. So different here is 0.217. Okay, kat sini you nampak macam dia ada dua unknown, which is Z2 dengan H. So actually you can masukkan nilai Z2 as 1.414. Kalau you tak nak masukkan pun, but later on, dia boleh cancel lah this one. 8829 Z. Bawa ke sini, so dia jadi tolak-tolak, so tak ada dah Z. Lastly, we only have one unknown sahaja. Ni masukkanlah kat sini sorry. Cancel, sorry. Dia masukkan kat sini. 1.14 ialah Z2 minus Z1. Okay, ni Z1 Okay, so for this question, ada soalan? Ada soalan ke?
Masih okey doktor.
Okay, masuk okay. So, kita tengok next examples. Sama je soalan dia. So, let's see the information. So, this is Q. 63 is the H. Pressure energy. They need you to find the CD. Okay, we don't have the CD. What is the TCM ni? This is the H level inside the manometer. 63. This one, the TCM ni apa? Okay, this the TCM is the Z. The vertical distance from point 1 to point 2. This one. Vertical distance from point 1 and point 2. Z. So the H is 63 kat sini. Okay. So this one dia cari specific weight. Specific weight betul lah. Specific weight is rho G. Okay. Samalah untuk mercury and oil. Oil is for the pipe. Mercury is inside the venturimeter. Okay, and then we also have to find the H. Sebab formula for pressure is rho GH ataupun specific weight H. So for left limb, H dia adalah H1 sahaja. Okay, for right limb, we have H2 plus 0.63. Okay, so substitute into the left limb and right limb. So left limb ada satu je types of fluid. Betul? Limb ada dua lah, mercury and also oil. Okay, then we equating both limb. So we can have the pressure difference. Later you all can check lah. Either we have the correct answer, 81.3 kilopascal. Okay, tadi soalan dia tanya CD kan? So CD, of course you need to follow with Bernoulli equations and also continuity equation. Ni baru cari pressure, belum masuk pressure energy. So before that, we can use the Q dulu, continuity equations, to find the V2. Okay, but this time we have two unknowns sebab kita tak tahu both velocity. So just leave like that, where the V2 is equal to 6.25 V1. Biarkan dulu. Okay, and then we can apply in the Bernoulli equations. So substitute the V2 menjadi V1. So we have the same variable. So bila dah sama V1, we can solve lah. We can tolak. And finally, we only have one unknown, V1. So the Q actual or Q real by multiplying the coefficient discharge with the Q theory. Okay, so macam mana dapat Q theory ni? Samalah. Q equals to AV. So area ni always referring to area of the pipe. bukan area of the throat. So area dia berapa diameter of the pipe? Berapa diameter of the pipe? 250. Okay, can you help me to calculate this one? Betul tak dapat 0.128? 0.25 kan? 0.25 square divided by 4 times the velocity of 1. Kenapa kita guna velocity of 1? Kita kena ambil velocity of the pipe, bukan velocity of the throat. So, 2.207. Dapat tak 0.108?
Dapat.
Okay, good. So, 0.095 ni adalah from the question here. Okay, so Q real bagi dengan Q theory, you get the coefficient discharge in between 0 to 1. So, coefficient discharge ni tak ada unit lah. Boleh? Ada yang tanya soalan? Macam mana kita nak tahu yang mana Q theory, yang mana Q real? Saya pula tak
Itu
tahu.
saya pun nak tanya doktor.
Ha? Putus-putus lah.
Q teori memang kena ambil daripada V1 ke?
Itu tadi awak tak ada soalan, saya tanya you all. So tak tahu kan soalan macam mana dapat Q theory dan Q real. So saya explain lah. Q theory, tadi Arif tanya Q theory mesti ambil Q1 ke? Ya betul. Sebab kita kena ambil Q entering. Q pipe, bukan Q throat. Okay, and then kenapa kita panggil dia sebagai Q theory yang kita kira ni? Q theory ni bila you calculate tak guna coefficients, dia adalah Q theory. Kalau you calculate, you masukkan coefficients, dia jadi Q actual. Ataupun Q real. Okay, so kat sini kan kita dah consider the coefficients. So we calculated the Q real. So calculated yang tak ada melibatkan coefficients, we consider as Q theory. Boleh Okay, so finish untuk venturimeter. So I need to go through orifice a little bit. So before that, need you to try this one. This question for venturimeter. We will discuss this one during our next class. Sekejap. Boleh copy lah. Sekejap saya share. Okay, now you can see the question. Nampak tak? Soalan dia tak bagi gambar dan the marks is bigger. The marks is tinggi lah 15 langkah. Okay, you can try this one. Maybe let's see some of the clue. Venturimeter is fitted in the horizontal pipe. Given the diameter is 350, this is diameter of the pipe. So we label as D1 maybe. And we have the diameter of the throat, this is D2. And we use, the venturimeter is used to measure the flow of the liquid. So the liquid is not water lah, it is maybe oil. 0.95. What is relative density? Soalan kuis hari tu. Ramai juga tak jawab. Tak dapat jawab. Relative density ialah apa? Specific gravity. SG. Okay, and then given that the pressure at the inlet, so maksud dia pressure of the pipe, bukan pressure of the throat. So this is P1. Dia bagi dalam unit bar. You need to convert to kilopascal. You can refer to your notes from properties. Okay. So meanwhile, the pressure at the throat is, dia bagi pula pressure in throat dalam unit millimeter mercury. Tadi dia bagi dalam bar. So all you need to convert to kilopascal. Ataupun pascal. Okay. So they also given you the CD. CD value is 0.96. So dia nak cari Q actual ataupun Q real. Q actual to CD times Q theory. Oops. Okay. Boleh try lah. All the conversions of the unit you can refer to topic properties. We will discuss this question on next class. So let's continue for orifice. Okay, boleh? Can take note this one? Boleh kan?
Baik, Doktor.
Okay, thank you. Okay, let's see the orifice. Before that, are you still remember where we need to use orifice? Dekat closed conduit or open conduit or both?
Orifice hole.
Oh, hole. Betul. Holes. Tapi kat mana kita nak guna dia? Dekat open channel ke closed channel? Where we can find the orifice? Kat mana kita jumpa orifice ni?
Water tank. Closed channel.
Water tank, yeah. Open water tank, open channel. Good, thank you Najmi. Okay, so ni dah saya dah explain dah sikit lah. Kita ada opening, it can be at the side of the tank ataupun dekat base. Okay, ni saya dah mention juga, water that come out from the orifice, we call as water jet. Okay, so sama dengan venturimeter. So you can see here it's mentioned that orifice is actually similar with venturimeter. Kenapa dia cakap similar? Because we have 2 point. Okay, kita ada dua point which is dia ada difference diameter. Okay, so bila dia keluar sebagai water jet, sebenarnya air yang keluar daripada as water jet ni dia mengecil. Flow dia mengecil sebenarnya. Okay. finally dia akan mengecil kat bahagian depan. So we have the area of orifice dekat opening ni, and we also has area of the water jet. Okay, smaller. So kita ada dua area lah. We have bigger area and also small area, or we can call as area of orifice and area of jet, AJ. Okay, so that's why concept dia looks like similar with the Venturi meter. Okay, so this one also need to follow Bernoulli equations, and by using this one we can cancel the necessary part. Macam biasalah yang ni you dah learn previously. What happened at the tank? The tank ni V dia 0. Apa lagi 0? Pressure dia sama. Pressure at point A and pressure at point B sama. So sama pun boleh cancel. 0 pun boleh cancel. Okay, PA and PB sama. So we can neglect. VA kosong sebab dia daripada tank. There is no flow of VA. So ZA minus ZB is the H lah. Dia punya difference of height. Okay, and then we can calculate the VB. Finally, V theory is equals to square H. Ini dah jadi H. So kat sini you dapat VB minus 2G equals to H. That's why last kali dapat formula V theory equals to square root 2GH. So now already you know that velocity for velocity for pitot tube dengan orifice sama, which is square root 2GH. Okay, so sama. For Q actual, we need the coefficient discharge. Kat sini samalah sebenarnya. TD is equals to AV. Nampak macam pelik kan kat sini. Tapi sebenarnya V ni, dia dah guna square root 2GH lah. Sama je. From the pitot tube. Okay, but for orifice, dia ada more calculations that involve the water jet. So let's see on the water jet punya calculations. Okay, so actual velocity is calculated on the velocity of the jet. It will be less from the V theory because of the energy losses between A and B. So from this sentence, you can know that velocity of jet, kita panggil the actual velocity. Velocity of the orifice is theory, is actual. Sorry, sekejap. Velocity of the jet ialah actual. Velocity of the orifice ialah theory. Okay, so you can see here. Q actual dengan Q theory sebenarnya adalah Q jet and Q orifice. Okay, so actual velocity must be at point B because it is at water jet. So it is CV darab dengan V theory. Okay, sebab dia velocity, so dia punya coefficient mestilah CV, tak bolehlah CD. Okay, CD is for discharge. Okay, so another point untuk orifice, kita ada CC, coefficient contraction. Okay, CC ni adalah coefficients for area. CV adalah coefficients for velocity. CD adalah coefficients for discharge. Okay. So sebenarnya formula asal kita belajar Q equals to AV. But each of the parameter ni dia ada its own coefficient. So coefficient of A tadi CC kan? So it is actually CC times area. Okay, darab lagi. V ni dia ada coefficient dia sendiri. It is CV times V. So this is Q. Okay, and finally, we also can rewrite as CC dengan CV ni adalah CD. So finally, kita boleh juga kira CD equals to AB. Macam itulah. So kenapa kita ada banyak jenis questions ni? Sebab sometimes soalan tak bagi nilai CD. Dia bagi CC. Macam itulah. Okay, that's why you can have multiple various equations, depends on the soalan punya information. Okay, so kalau dia tak bagi, dia bagi CV je, of course you need to find CC. So how we calculate CC? CC ialah area of the jet bahagi dengan area of the orifice. Okay, in case they give you CC but tak bagi CV, so we can calculate the CV where V of the jet bahagi dengan V theory. Okay, so V of the jet bahagi dengan V orifice. Okay, V of the jet bahagi dengan V orifice. Okay, let's see on the examples. Sebelum tu, if you still remember, I already also mentioned orifice also can measure T, time taken to empty the tank. So untuk empty the tank, basically the orifice is at the bottom, at the base of the tank. So this is A, smaller a. It is area of orifice. And this capital A is area of the tank. Okay, area dia sama lah. Kita tak guna area petak pun. Kita guna pi d square over 4. Sama je. Okay, so this D is capital A. Area of orifice is smaller a. Okay, so formula dia T equals to 2 times area of tank darab dengan H is the height of full tank. Okay, H1 ialah full tank. Minus dengan H2, H2 adalah level of water yang mana kita nak pergi kurangkan. Contoh kita nak clean up the water up to this line. Okay, so H2 adalah final elevations of the tank, H2, power of 0.5 and then square root CD, area is area of orifice here, darab dengan square root 2G. Okay, so untuk time, untuk empty the tank ni, formula dia bagi. This formula will be given. So yang you kena ingat untuk flow measurement ni yang tadilah. V for ventrimeter and the same thing V for pitot tube and orifice. Okay, so back to examples. With the value, we have the given the CV and also CC. So you can calculate CD. CD adalah CC times CV. Okay, why we need CD? Because we need to find the discharge Q. Diameter of water jet. Kita tahu diameter kat sini smaller part ni smaller. mau lepat water jet. Okay, and then of course velocity of the water jet. Okay, we can find the area first, area of orifice. So dia dah bagi CC, nak cari area of jet. Area of jet adalah CC darab dengan area of orifice. So now we can get the area of jet. Bila dapat area of jet, we can find the diameter of the jet. Okay. And then bila dah ada area, of course we can calculate the velocity. So velocity of orifice kita guna square root 2GH. Kena darab dengan CV because it is velocity. Jangan salah dia punya C. CC tadi untuk area, CD untuk discharge, CV untuk velocity. Okay, so substitute the 2GH. H is referring to here. 6 meter. So we get the velocity of the jet is 10.52 meter per second. Okay, and then untuk Q actual, kita kena calculate CD dulu. CC, CV darab CC. And then darab dengan area. Area adalah area apa? Tadi saya cakap actual dekat jet ke dekat orifice? Actual measurement of Q dekat jet ke dekat orifice? Ni area of orifice Okay, so finally you can get the Q actual. Okay, so setakat ni okay tak? Later you can go through again lah. Then we also have to calculate berapa jarak water jet ni pergi. Jarak tu dia ada dua terms, which is X and also Y. Jarak dia adalah X dengan Y. X directions and also berapa tinggi water jet can give. Okay, so dia ada head 1.2 meter. Coefficients of velocity is CV. Fall vertically y 0.5 and horizontal distance is 1.5 from the vena contracta. Vena contracta is diameter of the orifice. Okay, so we use this formula. V actual equal to square root gx square over 2y. Ataupun T equal to square root 2y over g. Okay. G is 981. Tadi dah bagi X punya value 1.5. Y punya value is 0.5. So you can get the V actual is 4.7. So V theory kita guna square root 2GH. 2 darab 981 darab 1.2. So 1.2 ialah tinggi water level tank to the opening of orifice. Okay, so dah dapat V actual dengan V theory, you can find the coefficient velocity where V actual bahagi dengan V theory. Okay. Bila masa nak guna equation ni, bila masa nak guna teknik Bernoulli tadi, all is depends on the information given. Kalau nampak soalan ni bagi X dengan Y, kita tak gunalah Bernoulli principle. We directly use this formula to find the V actual. Sebab kita tak boleh cari pressure. Sebab pressure tak bagi langsung kat sini. Okay, kita ikut kesesuaian information given on the question. So, kita pilih formula yang bersesuaian. Okay, another try yourself. Dia tanya flow rate through the orifice. Dia bagi head adalah 2 meter. Ni ada time taken ni. So, mestilah empty the tank. Or stop the time taken to lower head from 2 to 0.5. Ni lah. Ni adalah time to empty the tank daripada 2 meter kepada 0.75 meter. Okay. So, T area times H1 minus H2, CD and smaller area. So, ada different lah. The bigger area is area of the tank. Smaller area is area of the orifice. Okay. So, formula dia sama lah. This is pi r squared. Dia guna pi r squared kat sini. Kenapa dia guna pi r saja je lah tu. Padahal dia bagi in diameter. So, basically kita guna directly from here. Je tak payah bahagi 2. Sebab sometimes you always terlupa untuk jadikan dia radius. So, avoid lah macam ni. Kita guna based on the information given. Kalau dia bagi diameter, you guna formula diameter. So, kalau dia bagi area, you kena guna formula area. Formula guna radius, pi r squared. Okay, finally you can get the CD. Ada soalan tak? Okay, ni tak habis lagi, baru dapat CD. Dia tanya apa tadi? Flow rate. Dia nak flow rate. Panjang lagi question dia. Baru dapat CD, lepas tu kita boleh calculate V theory using 2GH. H ni adalah full tank. Full tank tadi 2 meter. Okay, and then we calculate Q theory, which is area darab dengan V. So, area adalah area of the orifice. Darab dengan V yang kita kira tadi. So, ini adalah teori sebab tak ada CD. Bila kita apply coefficients, the Q jadi real. Baru jadi Q real. Okay, so sama je. CD adalah, Q dia adalah AV, tapi dia ada CD. Okay, so kat sini sebenarnya sama je. CD darab area darab V. Okay, so area darab V, kita dah kira tadi. So, kita kena masukkan saja. Okay, bila kita use coefficients, dia jadi Q actual, Q real. Boleh?
Boleh, doktor.
Okay. So you have another 40 minit lagi. So I have another question for orifice. Tadi soalan venturi meter kan? Sebab kat sini semua try yourself dah ada jawapan. So you tak boleh try. So let me share another question. Wait. Okay, now I find. Ada soalan tak? Boleh follow tak? Boleh follow, saya akan share attitude saya punya recorded video. What is the question? Okay, now can you see? Oh, ni sama macam tadi. Silap. Thanks. Okay, now can you see? Nampak tak ke?
Nampak, Doktor?
Okay, so let's discuss a little bit on this. Water discharge from a storage, tak nampak lah. Through a tank, a sharp edge orifice. Orifice ni ada dua jenis. Kalau you perasan dia selalu guna sharp edge, lagi satu broad edge. Beza dia adalah size of the water jet. Kalau sharp tu maksudnya water jet dia tajam. Kalau broad, lebih tebal lah. Okay, so there is a difference between sharp edge dengan broad edge. Dia bagi diameter of the orifice ialah 4 diameter 4 cm. We have the head of the storage tank is 1.1 meter, and then we have the collected in the tank. They have the diameter of the tank is 1.4. Level of the tank rises to 1.5 meter. Time is 9 minutes. Given the diameter of the water jet at the vena contracta. Dia panggil diameter of water jet tu dekat vena contracta. Okay, so vena contracta ni adalah place where the water jet become smaller. Okay. Calculate the coefficient discharge CD. CD boleh dapat daripada Q. And CC dapat kat mana? Kat mana nak kira CC tadi? Ini idea. Tadi CD dekat discharge. CV dekat velocity. CC? Kat mana saya cakap tadi? CC is coefficient for what?
Area of jet over area of
yes,
orifice.
good.
Doctor.
Thank you. This is area. Okay. CC is the coefficients for area. Bolehlah cari. Boleh kan? Macam mana kita nak kira first step ni? Macam information dia sikit je kan? Bukan information dia sikit. Information dia berbeza daripada soalan-soalan examples yang you dapatkan. If you still remember, there is another formula to find the Q. Apa dia? Lain daripada Q equals to AV. Siapa ingat? Sebelum ni kita guna Q sama dengan AV, Q sama dengan AV. So this time discussion change sikit. They don't given you any velocity. Macam mana kita nak cari Q? Using another formula without velocity. Ada siapa yang ingat? Siapa yang tulis ke? Boleh check balik lah. Apa? It is based on the units for Q. Apa unit Q? Meter cube per second. So from the meter cube per second, meter cube ialah volume. Second ialah time. Discharge dia adalah collected volume. Okay, so kita kena cari volume of the cylindrical tank. So V is volume of cylinder bahagi dengan time. Time dia in second. So this G is 9/60. Formula volume for cylinder apa? Volume for cylinder. Anyone? Good. Thank you. Okay. So saya dah bagi clue dah. You can continue this one. So saya tak nak saya yang present next week. Macam saya juga jawab. So for next class saya nak Nazril ada? Ada tak Nazril? Nazril? Siapa kelas cakap lupa lah. Sorry. Nazril Syarif?
Azim.
Azim. Nanti bagi tahu Nazril sebab dia tak jawab ni. Soalan 1 tadi saya nak Nazril jawab. Boleh?
Saya ada doktor.
Nazril boleh tolong jawab
Baik doktor.
Okay, good. Sekejap, another one. Cari saya nak bagi peluang untuk yang dapat markah rendah-rendah sikit nak jawab ni. Tapi Nazril tak rendah lah. Tapi saya pilih Nazril. Next is Amanina Husna. Ada? Amanina?
Yes,
Awak jawab soalan orifice
okay.
Okay, Nazril jawab soalan venturing user. Okay. I think I stop here. Thank you very much. Bye. Assalamualaikum. Take care.
Thank you
Thank you,
doktor.
Doctor.
Salam doktor.
Thank you doktor.
Thank you doktor.
Thank you doktor.
Thank you doktor.
Doktor.
Nasib hati, sebenarnya.